like, this is just almost like a review of grade 9 stuff for the first little bit, okay? And then if any point you can't see something or like you don't understand, just let me know, and then we'll address it, okay? So we're just going to review solving equations, right? And then on every lesson, on the top right corner, you're going to have like basically the big idea, the thing that you're going to have to like try and solve or like figure out. And then underneath is what we call the success criteria, like the things that you should know how to do in order to achieve that goal. Does that make sense? So I've done that on every lesson. Okay, so as long as you can do like, or you know what the success criteria are, you should be okay. Okay, so for this, for solving linear equations, we want to successfully be able to move things from one side of an equal sign to another. Okay, so you guys should have done that in grade 9. So that just means like, if it's addition on one side, I can subtract from both sides, and then that's how we move things from one side to the other. We'll do that today, okay? And then collecting like terms, so that's like adding apples with apples and bananas with bananas, right? That'd be like x's and x's and numbers with numbers, okay? And then isolating for the variable of interest. So that basically comes down to like, if it's multiplying on one side, I'm going to divide both sides by that number to get it to cancel, basically. Those are like your three kind of like success criteria, right? And that's ultimately going to allow us to like isolate and solve for something. So x is equal to this. That's the goal today. So can you tell me what the variable is equal to? Okay, does that make sense? So I've done my best to put all that on all the lessons. Okay, so if you're in doubt and you need to know, okay, what do I need to do in order to be successful with this lesson, just look at that stuff. Okay, so if we take a look at so an equation, okay, is a mathematical statement that says two expressions are equal. Okay, so down here on these two lines, both of these things are what we call expressions. Okay, everyone has this paper, right? Okay, and when you have two expressions that are equal to each other, that's going to be what's called an equation. That's how we like build it up, right? So these two things turn into an equation. Okay, equations allow us to solve for variables. Okay. Okay, so this blank's going to be solved. To solve is to find the value of the variable that makes the statement true. Okay, so you should have, if you were in grade 9, you found what the variable was. To check if you were right or wrong, you could have plugged it back in for x. And then if both sides are equal, then you know the variable that you've solved for is equal. It makes sense, it works, right? That's what we call checking. Okay, so example 1, let's just take a look here. Okay, so this is like a word problem. I'll guide you through to like how to like come up with the equation. Then we're just gonna solve, right? So the cost to produce school T-shirts is modeled by the equation. Actually, I even told you the equation, so that's easy. Okay, where C is the total cost and N is the number of T-shirts. Okay, so it tells you what the variables are in this equation. Okay, so part A here is like, how much would it cost to produce 400 T-shirts? Okay, this would be something like the school's ordering KCVI clothing, right? This would be something that they need to figure out, like how many, like if we know the cost of like producing them, how many of them do we have to sell in order to like break even, basically, right? That'd be like something that they're going to try and figure out downstairs, right? And if we need 400 of these things to break even, and they only sell 300, then it doesn't financially make sense. Does that make sense? So you're like making decisions using math. That's what math does for us, right? And it provides us a layer of to make decisions, an extra layer, okay? So with this, what I'm going to do is write out C equals, I'm just going to rewrite the equation, okay? Nothing too fancy. So it's 1200 plus 4n, okay? Now, what are we interested in? We're interested in how much would it cost? Well, C represents the cost, right? And then over here, we have a number of shirts. N is the number of shirts. So we go find it in our equation. Okay? So all we have to do is I want to figure out what cost. Cost is equal to 1,200 plus 4 times the 400. Right? You're just physically replacing the N with whatever it is they're asking you to replace it with. If it was 500, you'd put 500 in there. If it was 2, you'd put 2. Right? And then it would tell you the cost. How much is it going to cost you to produce that number of shirts? That's what this equation is doing for you. Okay, does that make sense? So now we can actually, now it's just a calculator exercise. Right? All we have to do here, let's go C equals 1,200 plus, do we all know what the bracket implies? Sorry. Yeah, so the brackets imply multiplication. Okay? If you don't see an order of operation like an addition or subtraction or anything like that, that implies the multiplication. Brackets. Okay? So 4 times 400, what do you think that is? 1,600. How did you do that? What's 4 times 4? 16 with 2 zeros on it is the quick mental math, okay? So 1,600. And then so the total cost for producing 400 shirts would be what? Good. So that's 1,200 plus 1,600, right? Or 12 plus 16 with 2 zeros. And you could in theory say, okay, well therefore it will cost okay, I would say that when the equation's written in that particular way where the thing we're looking for is on the left side, and then we're just plugging things into the right, that would be the easier of the two situations. Okay, what you would have done in grade 9 is what we're about to do. Okay, so in the event that you, and it's very realistic, you have this much money, you want to find out how many shirts you can get. Right? So all we're going to do is go backwards now. We've reversed the question. So in part B here, it says you've got $8,000 available to you. How many shirts can you buy with that $8,000? Right? So all you got to do is we've just flipped where you're plugging in the numbers. That's it. Right? Remember what C was. C was the cost. So in theory, you could flip around and say, okay, well, the 8,000 is just the C value now. That make sense? So I always write maybe too many steps for some people's liking, but it keeps me organized. So I always get in the habit of just rewriting the equation. You don't have to, but I always do it anyway, right? So that every time I start to answer a new question, I know what I'm doing and what I'm plugging in where, right? So I always just make it a habit of writing the equation again. And this time I see a dollar sign on the number that they give me, which basically just implies the cost value, right? So I'm just going to replace C with 8,000. Okay. Now I need to somehow, you can see the N is kind of buried with the 4 here, right? So there's some things that we have to do in a sequential order to get to the 4, or to the N ultimately, right? The first easy step, you kind of want to go in the easiest order that you can. I would say addition and subtraction is a little bit easier than multiplication and division, right? So if you see any like addition subtraction in your equation, you deal with that first. Okay? And so by that I mean, okay, I'm going to take the 1200 and I'm going to try and move it to the left side of the equation, right? I'm trying to get it away from the n so that I can find n, right? So I'm going to bring it over to the other side, and I do that. Is it positive or negative on this on the right side? It's positive. So to get it to the other side, you could subtract 1200 from both sides. Okay? 1200 minus 1200, they now cancel each other out. Right? So your next line is going to be, and you can, addition, subtraction, you can write in any order. Okay? Doesn't matter as long as you keep track of the sign that's on the number. Okay, so negative 1200 plus 8,000 is going to equal the same number as 8,000 minus 1200. As long as you keep track of the negative sign, right? And then since I've gotten rid of the 1200 on the right side, that's equal to 4n. So what is 8,000 minus 1200? 6,800. Okay. So we're going to get 6,800 is equal to 4n. We're getting closer. Remember, the goal here is just to get n by itself. Okay, so how do I do that? What's it attached with? Say that again. You got to divide, yeah. It's hard to hear with the math on. I can't, like... Is that what you said? Divide? Yeah. It's hard to... Sometimes if I can't hear you, but particularly at the back, I could, like, read your lips, but I can't do that because that's just impossible now, right? So I'm just going to divide both sides by 4, right? Because it's attached with multiplication on the right side. So the opposite of multiplying is dividing. The 4's now cancel, because what's 4 divided by 4? 1n is now what it's turned into. And then we basically have n by itself now. So you should get n equals 6,800 divided by 4. Who wants to do that? 1,700. Okay, so therefore, you can buy 1,700 shirts, right, with $8,000. Do you have any major issues? Okay. It really doesn't change too much as you do these things. It's just sometimes the equations get a little bit more complicated, right? But the idea is the same. You're trying to find the variable, one of them. Okay, you'll have an equation that represents some situation. Doesn't matter how complicated the equation looks. If it asks you to solve for something, you're trying to find the variable that makes both sides equal. Both pieces of the expression, okay? So this is just going to kick it up one notch, okay? Just got a little bit more of a difficult equation, that's all. So a formula was developed to determine the strength of the taste of chocolate in different chocolate drinks, okay? So the formula, S is strength, is equal to 3c squared minus 2, where S is the strength, the taste of chocolate in Yahoos. It's just they're just making up a random unit, I think, unless a Yahoo's an actual thing, I don't know. And C is the amount of chocolate needed in grams. Okay. What would the strength of chocolate taste be if 39 grams of chocolate were used? What's that? A high number. We could figure out exactly what the high number might be. Okay. So again, my first step is always I like to just write out the equation. Okay. I don't know, it gives me a sense of like, okay, S is the strength, 3c squared minus 2. Okay. Now we got to add, remember S is going to be the strength. And we could say C is going to be the amount of chocolate. Okay, so this is like part A of the first question. We're just going to plug in the C value. And it's going to spit out what the strength of the drink's going to be in Yahoo's, whatever that unit is. Okay, so S is equal to 3 times 39 squared minus 2. Now, some of this is kind of geared towards, can you do this in the correct order? That's kind of why we're doing this question too. Because you're going to run into all sorts of situations in this course where you're going to have to be able to like do orders of operations in the correct order. Okay, so by orders of operations should prompt a particular acronym in your head. What is it? Bed mass. Okay, you're gonna run into all this. This always comes up, and like it basically it says that you're not allowed to multiply the 39 by 3 until you've squared it. You have to do that first because there's an exponent. The exponent in bed mass comes before division and multiplication. Okay, so you have to deal with that and addition subtraction. So you're not going to minus 2 from anything either, right? This is addition subtractions at like the very end with bed mass. It's like the last thing you do, right? So let's take care. So what's 39 squared? That's a big number. So it's 3 times. Okay. That number is from 39 squared. Try to keep track of stuff for you guys here. Okay. And now you just do that. Now it's a calculator. 3 times 1521 should be some number. Good. Minus 2. 4,561. Okay. So therefore, the strength. We're going to do a lot of word problems in this course too. So it's always like, it's good to summarize your findings with like, therefore statements, like kind of make meaning of the thing you just found, right? So that you can actually answer questions about what you just did, right? Sometimes we'll be given, there will be points in time where we haven't assigned any sort of like situation to the variables, then you don't really need therefore statements because they're just points. But if we do word problems, you're going to want to contextualize what those answers mean, right? And that's what we're doing with therefore statements. The strength of the okay. The next one's just a little bit trickier. Again, we're just knocking it up one notch at a time here, okay? So if a company wants a strength of 25 Yahoos, this is the same question as before, basically, right? I'm just going to I'm going to rewrite the equation. Okay? Strength of 25 Yahoos. So strength is the key word here. So I'm going to replace the S with 25. So 25 is equal to 3c squared minus 2. So this time I'm after how much chocolate is needed, right? So the easy thing here is to move the 2 over. Always start with the easiest thing, right? So you're going to move, basically going to add 2 to both sides, right? So you're going to get 25 plus 2 on the left side. It's going to be 27 is equal to 3c squared. I'm after just C. So I see the multiplication there. I can divide both sides by 3. Okay. The 3's now drop out. What's 27 divided by 3? 9. Right? So 9 equals C squared. Now here's a problem. I don't have C equals 9. I have C squared equals 9. Do we have a thing on our calculator that is kind of like the opposite of squaring something? We're going to do some of this in this course too. I'm just pushing the envelope a little bit. Do you or do you not have a button on your calculator that looks something like this? Square root. If you square something, you can square root it, and that's like multiplication division. They're like opposites. Okay? So in this question, C is going to equal 3. Yeah, buddy. Yeah. Okay? If I wanted to check and make sure that I was right, I could use the equation again. Okay? It'll be 3 times what the C value I found. 3 squared minus 2. Remember from the first part, I got to deal with the squared first, so C is going to equal 3 times 9, because 3 squared turns into 9, minus 2. C is equal to 3 times 9 is 27, minus 2, so C is equal to 25. That's how you know you're right. If you're able to take the value and plug it back into the equation and get what the original thing you were looking for, you know you have the right answer. It's a check. Okay? Okay, so you guys can turn the page over. So basically have kind of like a wordy problem thing now. Okay? So we're going to say, so we got this like, the width of a rectangle is 2 times the length plus 5. Okay, so this is good practice. We'll do lots of this in this course too, right? But we're going to say, you could basically go through, if you struggle like with word problems like most people do, you can go through here and say, okay, well, I'm going to say W for width. I'm just going to try and shorten the question, okay? The width of a rectangle is 2 times. What do you think the word times means? Just multiply, right? So I'm just going to go, okay, well, 2 times L plus 5. Right? I'm just trying to make it a little bit more mathy and less wordy. What are the dimensions if the perimeter is 70? Okay, so we're just going to say let W be the width. And what did we say? What did the question say the width was? Said W, the word is basically an equal sign. So W is equal to 2L plus 5. So that's what the words told me it was. Right? 2 times L plus 5. And then in the bottom one's easy. We're just going to say let L be the length, or L. Okay, so if I were to label this on my rectangle, the length always is kind of, I like making the length the long one. Doesn't really matter too much. And the width we're going to say is 2L plus 5. Okay? Any issues? Now so this one's asking, this is, again, we're just pushing the envelope, okay? When you see the homework questions today, they're going to be a lot easier than this. You're just going to be given the equations, going to say, solve for the variable. Okay? This would be like this question would be like the hardest one on the test, for instance, right? Where you're like, come up with the equation and then tell me what the dimensions are. There's a little bit of thinking there. Because you got to come up with the equation is the thinking part. Okay? So, remember what perimeter is equal to. What is perimeter? Perimeter is the distance around the outside of an object, right? Different objects have different perimeters, different equations, but for a rectangle, you're just going to add up the side lengths, right? So basically, you're going to go, I'll start in this corner, and I'm going to go up. It's going to be width plus length plus width plus length, right? So you basically get, okay, 2 L's plus 2 W's. Is that starting to look familiar? And then what they typically do, they just try to like make it as easy as they can. I see a 2 in both pieces here, they take it out. Okay, and then so their perimeter equation is the one you're probably most common with. Just means that we're going to add up the length and width, and then there's 2 of them because there's 4 sides, right? Whatever that number is. Okay, so that's the equation we're going to work with here. And then we're just going to throw in the things that we know. So we know the perimeter's number is what? It's asking us for the dimensions if the perimeter is 70. Okay, so 70 is equal to 2 L. And what did we say the W was? We said W was 2L plus 5 up here. Well, if W is equal to that, then why can't I just replace it as W down here? So you basically get plus 2L plus 5 because the W is equal to this. Is everybody okay with that? That's not an easy concept. It's okay if you're not. Okay, all I've done is it's told me what W was. It's the right side of this equation. So I just, okay, well if it's W is equal to that, then I must be able to replace it down here in the equation with it. Because it's told me that that's the case. Right? So now, we're in a position of like, I'm just going to try and solve for L. Right? So 70 is equal to 2 times, what's 1L plus 2L? This is like apples and bananas. So what's 1 apple plus 2 apples? 3 apples, right? So it's 2 times 3L plus 5. Okay. And then I'm going to try and get the variable by itself, the length. Okay, once I have the length, then I'm able to do some other stuff, okay? So, again, this is just a process. This is like a linear equation. I'm just trying to solve for a variable like on the first page here, okay? It's just buried a little bit more in this question, okay? But that just means you have 1 or 2 extra steps to get to the variable. So, you have to, in this particular question, divide the 2 out first. See how you have the brackets here? The brackets kind of act like a jail cell. You can't access anything in there until the brackets are gone. Which means I got to get rid of the 2 first. Okay? So I'm going to divide both sides by 2. That's going to knock the 2 out at the front. Right, they're going to cancel. Now it turns into a 1 because 2 divided by 2 is 1. What is 70 divided by 2? Does anybody know that? 35, okay. So that just means when we come up here, I don't know why I switch colors, by the way. I just sometimes just switch in the middle of a question. Doesn't mean anything, in case you're wondering. Is we get 35 is equal to, what's left? 3L plus 5. Well, it's starting to look a little bit easier now. There's no more brackets there. Right? So now I'm free to do, I can subtract 5 from both sides. I'll do that in a different color so you can see. So I'm just going to subtract 5 from both sides. So I get 35 minus 5 is equal to 3L, because the 5's wipe themselves out. And then I get 30 is equal to 3L. So then I just divide both sides by 3. They wipe themselves out. L equals 10. Okay. How many dimensions are there on any, well, on this rectangle? How many dimensions are there? 2. Right? I found one of them, but I still need to find the other one. How would I find the other one?
You just go back to your width equation in P path.
All right, so let's bounce back up here, right? I have something that tells me what the width is equal to. And it just so happens to have an L in it. Which means, okay, well, W equals 2L plus 5. So the width is going to be equal to 2. It told me what L was. I'm going to plug it in here. Right? It's 2 times 10. Oops. Plus 5. So the width is going to equal 2 times 10 is going to be 20. Plus 5. The width is 25. Is there any major concerns? That's a loaded question for day one. You know, that's probably as hard as that particular style of question is going to get, where you're not provided the equation. So you got to come up with it. That was step 1. And then you got to figure out what 2 dimensions are. But you had to write one of them in terms of the other. That's a pretty loaded question. Okay, it's okay to be lost in that question. That's a hard one. Okay, the important thing is, the bigger picture is, can you do the questions that are kind of in example 4? That's the basics. Okay, that's where we need you guys to be in order to do anything in this course. Okay, can I find what a variable is equal to? Okay, so we'll run through these 4 and then I'll give you some examples. What time do we go till? 9:40? I'll run through these ones. And they're not going to be any harder than what we just finished doing, okay? And then I'll give you some practice questions, okay? So, this one's nice, this question, the way it's written. When I say apples and bananas, or apples and oranges, whatever, I'm talking about things with variables on them relative to things without it. So in this question, we don't have anything on the 18. So that's, I'll zoom in maybe. I can do this one zoomed in a little bit more. Okay. There's nothing on the 18, so that's different from the ones with the x's. So I can't add them together. That's what we call collecting like terms, right? So all I have to do is like just a basic, you forget about the variable. The variable just denotes that they're similar. Then you just add or multiply the numbers and add the variable on. Okay, there's nothing fancy going on there. It's the exact same thing as it's just basic addition subtraction, okay? So I have 3 minus 1 minus 4. You can do it basically in any order you want either, right? Because it doesn't matter. So We'll just do it from left to right. 3 minus 1 is going to turn into negative 2x minus 4x is equal to 18. Ever see what happened? Sorry. I gotta look. 2. 3 minus 1 is 2, not negative 2. Okay. And then 2 minus 4 turns into negative 2x is equal to 18. Now this looks like something I can solve. I just divide both sides by the number that's up front, negative 2. Okay, so they wipe each other out. Now, anytime you see only one negative, it just means your answer is going to come out to be negative. You see two negatives, they cancel each other. So it's just math. Don't get confused by the negative. It's just 18 divided by 2 with a negative on it. That's it. If they were both negative, then you'd have a little bit of thinking to do. The negatives would cancel. Because it'd be like negative 1 divided by negative 1. That's just 1. Right? If you were to type that in your calculator. Right? But for this, it's just 18 divided by 2 with a negative on it. Okay? So 18 divided by 2 is 9 with a negative. Okay? Next question is not as nice because the apples and bananas are kind of like mixed up together. That's what's going on here. Okay, so we just got to figure out. I'm going to move this over here. And I'm going to take the number here and I'm going to move it to this side. I'm just trying to group the things that are the same. Right? So if I were to like go back here and highlight this. We've got some green pieces. And we've got some red pieces. Right? I want to get the red pieces on the same side. I want to get the green pieces on the other. Okay. So to do that, all I have to do is just apply the opposites, right? So I have a minus 2 on the left side. What's to stop me from adding 2 to both sides? And then they wipe themselves out. So the next line could be 5x is equal to 3x plus 16 plus 2. Now the problem is I still have a red piece on the right side. Okay. You can, at this stage, combine the two green pieces. Okay. I'm going to subtract 3x from both sides. And then they're going to wipe themselves out. And so I'm going to get 5x minus 3x. And I can combine these two pieces to be 18. Okay, so 5x minus 3x is going to be 2x. Okay, 2x is equal to 18. Divide both sides by 2. X is equal to 9. Okay. Now, the next two get a little bit more difficult. The last one's probably the hardest because, and like really, the only reason why it's the hardest is because we're pulling on some like prerequisite skills. So I'm just showing you all this stuff because this is like kind of things that you should have done in grade 9 that's going to benefit you, that you're actually going to use in grade 10. Okay, that's why we're doing this. Okay, so in number 3, I see some like jail cells here that I can't touch anything in there. Okay. What you're going to have to do with this question to get rid of the jail bars is to kind of like, you hop over them. When you hop over, it's multiplying. That's how you're going to kind of like escape these things. Okay. So I'll erase it a little bit just because it's easier to see. Okay, but what you're doing, you're going to go 2 times 14x, and then 2 times negative 11, and then you're going to do the same thing on the other side. Okay. The other side is negative as the catch. We'll do that in a sec. Okay. So on the left side, I'm going to do 2 times 14 again. If you just look at, this is just a number with something on it. Okay, it's nothing fancy. So it's just going to turn into number times number with something on it. It's 28x minus 22 is equal to, on the other side we haven't done anything yet, 40x. And then I've got a negative 2. That's going to go into both pieces. Negative 2 times 2 is going to be negative 4x. Negative 2 times negative 5 is plus 10. Okay. Now we're at the stage we can just start collecting like terms, okay? I see here on the right side, I see 2 that we could combine right off the bat before I do anything. So I'm going to get 28x minus 22 is equal to 40x minus 4x. It's going to be 36x plus 10. You can't forget about the thing on the end. Okay. Now I'm in the stage of I can get the like terms together. Okay. So however you choose to do that, whatever order, doesn't really matter. I'm going to subtract 36x from both sides. So I'm going to get 28x minus 36x is equal to 10 plus 22. Okay. What's our number here? It's 28 minus 36. Who wants to do that for me? Yes?
-8.
Okay. Ten plus 22. 32. What is x equal to? It's 32 divided, remember, it's just 32 divided by 8 with a negative on it. What's that? Yes?
-4.
Okay. Put a little box around it, make it clear. Okay.
For the math.
Math office is just it's the first door on the right, just past these double doors here. Yeah, just right hand or right.
Is it 202?
It might be, yeah. I don't know the number. It's the first door on the right there. Any issues? Look, you're gonna have a chance to practice these, okay, for a few minutes. What we'll do here, we'll do the last one. This is probably, it looks really hard because there's fractions in it. Everybody doesn't like fractions. Fractions are the best thing in the world because they keep exact values. You don't you don't make rounding errors with fractions because they're exact values. That's why we like them, right? So, but the rules still kind of apply. I see pieces with an x in it. Oh, here we go. It ain't working. Okay, just for, like, try this one here for a sec. Okay, get the 2 pieces with x in it on one side, and get the 2 pieces with a number in it on the other. There we go. Okay. So I'm going to take the x plus 6, I'm going to move to the other side. So I'm going to get x over 9 minus x over 6 plus 1/2. I'll do this in the second stage here. Okay, does everybody see what I did? It doesn't matter what the piece is. Okay, it doesn't matter how complicated it is. All you have to do is do my x over 6. Okay? And then I'm going to do the same thing with the 1/2. Okay? I'm going to throw it over, but when I do it, it has to become, I have to subtract it from both sides. Okay, so x minus x over 9 minus x over 6 has to equal 1 over 3 minus 1/2. Okay? Here's where everybody freaks out, doesn't know what to do anymore. What's the one single rule you need to know when adding and subtracting fractions? Yes?
Find the common denominator.
The common denominator. Okay? Most of the time you should be able to kind of like see within reason, like 1 or 2 or 3. Not 1, because that would be the same thing, but 2 or 3. If you multiplied the whole fraction by 2 or 3, you might start to see like the common number between the two, common denominator, right? So in this one, what do you think the first number is that you're going to hit between 9 and 6? Like if you were to start multiplying 9 and 6, which one would you hit first? 18. Okay, so that wasn't really a great question worded wise, but if we actually do the work on it, if I were to multiply the fraction, the first fraction, and when you do this, you can't just decide to multiply by 2 because that changes it. You can't change what's happened actually, right? So when I say multiply by 2, you have to multiply by 2 over 2 because that's still equal to 1. 2 divided by 2 is 1, right? So for instance, here, I'll get rid of this line here. Two divided by 2 is still 1, so I haven't changed anything, right? And then I'm going to try and do the same thing. How do I get 18 from 6? Six times 3 is 6 times 3 is 18. Okay, so if I do the same thing over here, okay. Now to actually solve this, we're going to go, okay, top times top, bottom times bottom. That's how we multiply fractions together. So I'm going to get 2x over 18 minus 3x over 18. Then I got to do the same thing to the other side. Okay. 1/3 minus 1/2. So the common denominator between 3 and 2, or the common number, would be 6. Right? So if I take the 1/3 and I multiply it by 2 over 2, and then I'm going to subtract the 1/2, but I need to get 6 in the bottom, so I'm going to have to multiply by 3 over 3. So I get 2 over 6 minus 3 over 6. Okay, now that the bottoms match, I'm actually able to do the addition subtraction. Okay. Again, this would be probably as hard as it's going to get for this side of things. Okay, but you need to know how to do this. You need to know how to work with fractions. That's an important piece. Okay. So 2 minus 3, again, it's just, forget about the x, it's just an apples. 2 apples minus 3 apples, right? On the left side is going to be negative x over 18 is equal to 2 minus 3 is negative 1 over 6. I need x by itself. So I'm going to multiply both sides by 18. Okay, so I get negative x is equal to negative 18 over 6. Okay, what is 18 divided by 6? And then I can divide both sides by negative 1 and the question's over. Okay, that drops those out. It's a loaded question. Do we have any issues, any questions just before I stop the recording? From a student perspective? Okay. Lots there. Okay.